In the upcoming session, we have Gaurav Jindal, Senior Business Development Manager, Government, Defence and Enterprise, Thales India, to share his presentation on best practices in encryption and data security. Thales provide data security through encryption, key management, access control and access intelligence across devices, processes, platforms and environments. Let's see what they have to share. Over to you, Mr. Jindal.
Good morning, everyone. This is Gaurav Jindal from Thales, and I handle the business development for government and enterprise. Today, I'm going to talk about the best practices in encryption and data security. So just to take you through the broad agenda, these are the points which I am going to cover. The latest key management trends which are prevalent in the industry today. What is centralized key management? How important it is and why does it matter? Best practices of cryptographic key lifecycle management, and a brief introduction of Thales Zero Trust Manager, which is a next generation solution. So this slide typically talks of the global trends, which as per the survey in the encryption industry, and the most important significant challenges which people have faced are outlined, which you can clearly see, is 48% of the respondents identified isolated or fragmented key management systems as a significant challenge, coupled with lack of skilled personnel and no clear ownership. So let's see how do we address all these points. So as the typical problem, a business problem is of too many silos. Organizations tend to encrypt their data at storage level, application level, file level, data lakes, cloud storage, etc., etc. So ideally, each one of those point solution requires its own contracts, maintenance, integration, etc. This approach is complex, inefficient, and creates high level of expense. So basically, the underlying fact is that fragmented approach means higher risks. So what are the best practices for a cryptographic key lifecycle management? So key generation, making sure that the strength of the keys generated are in accordance with the sensitivity of the data. Then the key access, to ensure that the person who is creating and managing the keys has no access to the protected data. Then how the keys are stored. Are they stored in a FIPS compliant 140-2 box, or are they lying anywhere in the system? Another key important point is key rotation, whether the keys are periodically rotated and documented. The versioning and the rotation has to be well documented. And finally, backup and recovery. Once the keys have been stored, in any untoward incident, it is mandatory and required that we should be able to recover the keys. So coupled with the earlier slide, basically a key lifecycle management essentially means strong authentication. For example, a two-factor authentication. Then audit trails. That is very important for compliance purposes. The system should be able to maintain logs and integrate with SIEMs to maintain requisite risk and compliance parameters. Flexibility of the solution. The solution should be able to be deployed across physical, virtual, and cloud environments. Then another important aspect where we discussed earlier, no clear ownership. So unified management, centralized management and secure storage of encryption keys and policies is very important. And third-party integration, whether the solution deployed will integrate with third-party application or no. So the growth of data has led to an associated use of encryption, which is almost in every industry. This has resulted in an increased number of keys that an organization has to manage and store. So ideally, the organizations must ask themselves the following questions: that once the solution is deployed, who will control the keys? Where are the keys located? Are the keys trusted? Can you trust the keys? And most essentially, will they pass an audit? Finally, whether they would work with my third-party applications or no. So ideally, here is a shared responsibility matrix, which has been there for quite some time. And most of the cloud providers even illustrate on their websites. So the idea of having this slide is that from left to right, if you see when you move up the chain, the responsibility of the service provider increases. But the point here to note is that even for software as a service, the responsibility of the data finally resides with customer only. So in whichever scenario it might be infrastructure as a service, platform as a service, or software as a service, the responsibility of the data continues to be with the customer. Here is a list of regulations which are followed globally by European unions and other countries, including India, Hong Kong, APAC level regulations, which we have. So basically, different regulations across the globe have outlined different compliance mechanisms on data security. If you closely see, almost everyone, here is the point which I was trying to make. If you closely see, almost everyone focuses on two things. One is encryption, tokenization, and separating the keys and the data. So the most essential part is how you encrypt a data using encryption techniques, tokenization techniques. And the second most important point, which all the regulatory authorities have come out with, is that the data and the keys should not be residing together. Basically, even if I talk of, from Indian perspective, I talk of RBI guidelines, it talks of securing keys through additional physical protection of equipment, ensuring key management is fully automated, and ensuring that the keys are changed frequently. So the basic question is, then where do you put the keys? So as per Cloud Security Alliance, which is a most trusted third party, unbiased third party dedicated entirely to the cloud security. According to Cloud Security Alliance, the keys shall not be maintained by the cloud service provider, but maintained by the cloud consumer or the trusted key management provider, which could be a key broker in between. So essentially what it means is that even if your data resides in the cloud, the control should be with the customer itself. So here is a typical use case of key management. Where does the key management come into picture? So protection against data loss, where systems are deployed with full disk encryption solution, allow role-based permissions, and protection against physical theft or disk drives through support of KMIP encryption keys for data at rest and data in motion. And second most important point is to meet the compliance and audit mandates. So basically, key management consolidates key security policies across multiple appliances, supports for FIPS 140-2, L1 and L3 for high compliance mandates, and support for data privacy standards like PCI DSS, HIPAA, GDPR, etc. Another use case for key management would be having a consolidated key management. So a centralized key management across all or your multiple endpoints, secure data located in disaster recovery sites through centralized and consistent enterprise-wide key management across physical and virtual data centers, data recovery sites, and your cloud infrastructure. So what is an ideal key management solution? So an ideal key management solution basically would be, which has a centralized key management. Your data might continue to reside in cloud, file servers, applications, storage, etc., etc. But the essence is that all these should be managed through a centralized key management solution. So the idea is to decrease the silos, which we had discussed in the earlier slides, which has come up as one of the major challenges. Once we have a centralized key management solution, we can control the access of the users depending on whether they are internal users, they are external users, their administrators, their employees, customer. So the access can be controlled accordingly. And unified key lifecycle management will ease the administration policies like we had discussed, rotation, key rotation, key expiry, key generation, stuff like that. And hence, this approach would mean lower risk and definitely lower cost. So here are the different stages of data security in a cloud. So typically, if we talk, the initial way of encrypting, and which is still prevalent, is encryption in software, that is by using the native encryption of the software itself. Then the second technique would be to use a cloud and use the cloud's own key management services. Now, the third and the fourth, which are, as we are discussing the latest trends, third and the fourth are the latest trends in key security. So bring your own key and bring your own encryption. So we'll talk about these in detail in the next slide. So here are the options for data encryption in cloud, as we discussed, depending on what kind of data you have in your organization. If it is a highly sensitive or confidential data like PII data, like your Aadhaar card information, your credit card information and stuff like that, then the ideal solution would be bring your own encryption along with access controls. If the data is a little less sensitive, then the ideal scenario would be a native cloud encryption coupled with bring your own key. And if the data is not classified data, it is available on public domain, then only a native cloud encryption can be deployed, and where the organizations are well aware of the risk and they are ready to take those kind of risks. To clearly understand the bring your own encryption and bring your own key while handling sensitive data. So the slide outlines all the three scenarios which we had spoken earlier. Basically, a cloud native encryption, when do you use it? When the cloud service provider is responsible for both encryption and cryptographic key management. The entire control is with the cloud service provider. He can encrypt everything. You have achieved the encryption, but basically there is no segregation of duties. There is no protection against rogue system administrators, APT, and subpoena, etc. So with a little more sensitive data, we talk of bring your own key, where the customers bring their own key and share it with the cloud service provider. They can protect at disk level and individual file level or containers. But the problem is that this process is entirely manual and is not automated. So the key lifecycle management is prone to human errors. System admin misses something, you are at risk. So finally, we talk of bring your own encryption, where customers, they own and manage their own keys. They encrypt the workloads before they upload it to the cloud. So essentially, they send the encrypted data to the cloud provider and the control remains with the customer itself. So the cloud is only used like a bank locker where you keep your valuables and the keys are with you. And it is applicable to multiple clouds. An organization might have Azure, AWS, Google. It could have multiple clouds. This bring your own encryption is applicable in all the scenarios. So this slide typically talks of, to break it down further, here we talk of cloud key lifecycle management comparison between bring your own encryption on the left side and bring your own key on the right side. So if you see in a entire lifecycle for bring your own encryption, you are the master. You create, you have the backup of the keys, you deploy, monitor, rotate, expire, archive, and finally destroy when the key is no longer needed. So you are controlling the entire lifecycle. You are just porting your encrypted data on a cloud service provider's data center. In the second scenario, bring your own keys. you definitely bring your own keys, you create your own keys, you might have a mechanism to back them up at your end. But rest of the life cycle is done and maintained by the cloud service provider. You can say maybe a 10 or 20% control on the entire life cycle. These are the three cornerstones of data protection, essentially. So when we talk of, first is access control, where we minimize the risk not only from outsiders, but insiders as well, including the root or system admin. So the higher risk comes from the insiders when the data is residing and the administrator is in control of the data as well as the keys. So obviously, he has the keys to the encrypted data. He can de-encrypt the data anytime he wants. So essentially, we're talking of giving controlled access to the users as and when required. Then encryption and tokenization, where we either we encrypt the data using key management or tokenization solution. Basically, encryption and tokenization are both open standards based on AES or FF1 and requires keys to be managed. So in both the cases, data can be protected at rest and in transit. So you achieve data security and privacy by design. And compliance, which we talked about earlier, which is an essential part. So compliance to all the regulations like PCI-DSS for banking, HIPAA for insurance, GDPR and stuff like that. And from Indian perspective today, UIDAI and etc. And finally, the key management. So the key management along with HSM, hardware security module. Here the users retain the control of cryptographic keys. The keys are basically put in a hardware security module. As the picture you can see, it is a hardened box, tamper-proof box where the keys are there. We have a centralized key management. So hence the silos which we are discussing earlier are minimized. The complexities are minimized. The cost is minimized. So the root of trust in form of hardware security module is there along with the centralized key management. From Thales perspective, here we have a one solution platform, basically Cypher, which is Cypher Trust Data Security Platform. This combines data discovery and classification of sensitive data with comprehensive data protection using encryption and tokenization. And finally, the key management across a single pane of glass. So it could be on premises, it could be on cloud, it could be for hybrid deployments as the customer wants it. So basically, the key highlights being that it gives you a single GUI to auto discover and classify sensitive data, your personally identifiable data. And it also helps you to remediate the risks using appropriate controls, that is encryption and tokenization. And finally, do the encryption key management, all from a single console. So basically, the key takeaways from the presentation would be, I would highlight them as that encrypting the data, such as your Aadhaar card, PAN, driving license, ration card, credit card, etc., bank account information. So that is one of the most key factors. Then turn your cybersecurity strategy inside out. So by starting to encrypt your most critical data, you ensure that even if an attacker passes your perimeter defense like firewalls or IPS or stuff like that, your data is totally locked down. It is in encrypted state and nobody can understand what it is. 90% of our customers use file level encryption and for structured as well as unstructured data. So that is one thing. And encrypted data and encryption keys, as we discussed, that they need to be kept in separate environment. They cannot be together. It is like having a lock and the key put in the same place. So anyone comes, picks up the keys and opens the lock. It cannot be like that. So the encrypted data and the keys have to be stored separately, as we discussed in cloud kind of an environment. The data resides with the cloud provider and the key resides with the customer, that is you. So for securing data in cloud, encryption of keys shall not be stored on the cloud, as we discussed. And data encryption prevents you against rising ransomware attacks, offers protection from insider threats, prevents database administrators, system admins, and root users from accessing your sensitive data. So that's all from my side. Thank you. And if there are any questions, my coordinates are there. I would be more than happy to answer them. Thanks.
Thank you, Mr. Jindal, for sharing best practices around data security, something which is much needed in today's time of fraud and breaches. Stay tuned for the next session.